Okay, we are going to work on this Aleks topic, solving a trigonometric equation, modeling a real-world situation. Suppose, I'll read this. Suppose that the height above the ground of a person sitting on a Ferris wheel is described by the following. Height in t, h of t, is 18.5 minus 16.4 cosine 2 pi over 5 t. In this equation, h of t is the height above ground in meters and t is the time in minutes. The ride begins at t equals 0 minutes. So because t of 0 is 0 and cosine of 0 is 1, then I know that my beginning height is going to be 18.5 minus 16.4. We're on a Ferris wheel here, so it's going to be 2.1 meters, and this cosine of 0, the minimum value is going to be negative 1 times 16.4, which means 18.5 plus 16.4 is 34.9. So the highest up here is going to be 34.9. So it's going to be somewhere in that range, and it's going to go up and down and up and down and up and down. So, we've got our, let me get a line here. We've got our time starting at 0, and we're at 2.1, and then we're going to go up to 34.9, and then down to, right, and then up again, and then down again. And it's going to look like that. Okay, and our B here is for our horizontal stretch is 5 over 2 pi. So it is horizontally stretched by 5 over 2 pi. The normal period is 2 pi for cosine, so the new period is going to be 2 pi b, or 5. So this period here is going to be 5. So that means it's going to hit the same height 2 times every 5 minutes, wherever we got here, unless we're at at the very top here. It'll only hit the top or the bottom once, but the other heights it's going to hit 2 times every 5 minutes. Okay, so we know something about what's happening here. So the question is, during the first 5 minutes of the ride, that's this period here, when will the person be 13 meters above the ground? So we want this h of t to be 13. So we're going to set that equal to 13, and we're going to move some stuff around. So in the end, I'm going to get 16.4 cosine of 2 pi over 5 t is equal to 18.5 minus 13, or 5.5. And I'm going to divide both sides by 16.4. And we're going to end up with cosine of 2 pi over 5 t is equal to 5.5 over 16.4. Now, we have the cosine over here, and what we want to find is inside here, so we're going to have to take the inverse operation. So I'm going to take the inverse cosine of both sides. Okay, and I'm going to end up, these will cancel each other out. I'm going to end up with 2 pi over 5 t is equal to the inverse cosine of 5.5 over 16.4. So that 5.5 over 16.4 is going to happen. Let me change my color here. That's going to happen somewhere like here, and then again right over here. So I know that my graph isn't perfect, but you can see it's going to happen somewhere. It's on the bottom of here. It's not, It's somewhere in the middle there. How about that? It's somewhere in between these two, and it's going to happen. It's going to happen both times. So the period of cosine is 2 pi. So if it didn't have this first 5 minutes, it talks about this first 5 minutes, so we're not actually interested in this part over here. But if we were, we would have to add, that plus 2k pi to all of our answers. We don't have to do that because it does say in the first 5 minutes. But if it doesn't say that, we're going to have to get all those times. Okay? So what do we want? We want to find the place where cosine is equal to 5.5 over 16.4. And if we look at our unit circle, cosine is positive when the y-axis is positive. So it's going to be happening in this quadrant here and in this quadrant here. So it's 5.5 over 16.4 is kind of small, so whoops. I am having a problem with my pen here. Okay. So it's going to be, it's going to be down somewhere low there. So we're going to have a reference angle here. So what we need to think about is we need to think this first one, when we solve this problem and take the inverse cosine, right? It's going to give us this reference angle over here. That's the answer we're going to get on a calculator. And then the other one is going to be this one over here, or pi minus that number. So we're going to end up having 2 here. We're going to end up having 2 pi over 5t is equal to the inverse cosine of 5.5 over 16.4. And, say and, but I mean or. And it's going to be 2 pi over 5. T is equal to pi minus that value. All right. So we'll figure those out, and then we'll solve for t. All right, well, we'll find this value using a calculator, and I always recommend that people check to make sure that they are using the right units. You have to make sure that your degrees and radians are in the correct setting. And here we're using radians, and I always say, check what tan 45 is. If tan 45 is equal to 1, because that is, lost my pen. That is this angle right there. It's going to be, same. It's going to be a nice isosceles triangle here. So tangent 45 is going to be 1 if you are in degrees. And if you don't get 1, then you're in radians, and you need to change it. And the problem is the calculators, they don't really all use the same method to show you how you're in radians or degrees. So if you're using a calculator that you're not familiar with, I suggest you use this method. Just check tan 45 and see if it's 1. If it's 1, you're in degrees, and if it's not 1, you're in radians. All right, so I hope that helps you solve this. I can't solve every problem for you, but kind of showed you how you need to model it out.